So in a minute I'll start lecturing on section 3.4. I just wanted to do a real quick review of a couple things from section 3.3 that I always put on the test and that are missed more than they probably should be. So the first style of problem that will almost guaranteed be on your test is a problem where I give you a function written as an equation and I ask you to find the domain but not the range. And then I'll also separately give you a function that's a polynomial and ask you to find its domain. So these are two separate problems. It would be nice if you could do each of these. Pause the video, do the problem, write your answer, then start the video up and check yourself. But if you're not ready for that, just watch me do this. So of the two, the first problem to find the domain of any fraction, I always ignore the numerator. So I'm going to ignore the x minus 3. I'm going to solve the denominator equal to 0. I'll just do that real quickly. Since it's just one step, I'm going to minus 8 from both sides. And then I'm going to write my answer. And if I want to write it in words, it's completely fine. I can say the domain is all real numbers except negative 8. Or I can write it as an interval. So that would be a correct answer. To write it as an interval, I can do it without the number line, but how we get the intervals is we create a number line with negative infinity on the far left edge, positive infinity on the far right edge, the number I'm excluding from the domain written between the infinities, and the interval notation would be the interval from negative infinity to negative 8, union the interval from negative 8 to infinity, all round parentheses when you do interval notation for the domain of a fraction. And then again, for those of you that are visual, if I took the time to graph this, the number that you'd get for setting the numerator equal to 0 is going to be an x-intercept, but it's not going to be like a defining part of the domain. The negative 8 that I got when I took the denominator and set it equal to 0, it's going to segment the graph into two pieces. And I think the pieces are going to look something like this. And I have my graphing calculator. But I believe the graph looks something like this, in that at negative 8, the graph is kind of separated into halves. The domain shows there's half of the graph to the left of negative 8 on the x-axis, and the other half of the graph is to the right of negative 8 on the x-axis, but the graph doesn't exist at negative 8. And the 3 isn't a breaking point in the graph, or it's not a left or a right edge. It's just the x-intercept, which has nothing to do with the domain. So I always emphasize that I'm always ignoring the numerator when I'm finding the domain of a fraction, because it doesn't impact. It's not something that's a feature in finding the domain. The next problem, finding the domain of a line, there's no algebra to do, and if you do any algebra, you'll likely get the x-intercept, which again has nothing to do with the domain. So for my answer to this, I can just kick the answer right out. I could either say the domain is all real numbers without any except, or as an interval I can say it's the interval from negative to positive infinity. If I wanted to graph this, because you're visual, if I wanted to graph this, I know the graph is a line. It's not necessary to graph, but if you're visual, here, the graph, I plot 6 on the x-axis, y-axis, slope is 2, so I'd go up 2 over 1. And the graph would look something like this. It's a line that extends forever, unbroken. The -3 that you'd get if you took the function instead of equal to 0 is going to be an x-intercept, but it has nothing to do with the domain. This is the kind of domain we did visually. This graph would extend to the point positive infinity to the upper left and negative infinity to the bottom. And the domain would be the x-coordinate of the far left point, which is negative infinity, and the x-coordinate of the far right point, which is positive infinity. The -3, that's the x-intercept. That's the thing that you'd get if you did the algebra of setting the problem equal to 0. It doesn't show up in the domain at all. And if in your answer to this second problem you show the -3 anywhere, your answer is completely wrong and you lose probably all points on the test. So that's one style of problem I wanted to review. And the other style of problem from 3.3 that I wanted to review would give me a function defined as a set of points. Like here's the function f defined as the points 1, 2, 2, 3, 5, 6, and 7, 9. Just completely made that up. And then I might do this. Find f of 2, and that'd be one kind of problem. And the second problem would be find all values of x such that f of x equal to 2. So we did just a couple of these in section 3.3, but I know I always put them on the test. Each of these problems is giving me either an x or a y value and asking me to find the other. So if the number that's given in the problem is in a parentheses, then that number is an x value, and I'm supposed to find the y that corresponds to that x. So in the first problem that I wrote, the 2, because it's in a parentheses, stands for an x value. I want 3 to be my answer. For my answer, I can write f of 2 equal to 3, or I can say y equal to 3. Those would be equivalently correct answers. And that's all that's asked for there. If you just wrote the number 3 down, I'd probably be equally content with that. The second problem that I wrote that relates to this function x, the number that's given is to the right of an equal sign, and when the number's to the right of an equal sign, it stands for a y value. So the 2 that's given in the second problem, because it's to the right of an equal sign, stands for a y. It asks me to find the x value, and I could write this for an answer, x equal to 1. If you wrote f of 1 equal to 2 by changing that x to 1, it also would be okay. So the domain questions and the function questions that don't require algebra are virtually guaranteed to be on your test. I would guess kind of 4 points each, so there's probably 16 points worth of the test that I just did on these last two problems that you're virtually certain to see. There's some other things in section 3.3 that are test worthy, but they're not missed near as much as these. And when I get to the review, you'll be able to see what else from this section was test worthy. All right, so the beginning of section 3.4 starts off wanting me to sketch a graph, and these aren't on the test, so it wouldn't hurt you. It would be okay if you skipped this part of the video if you wanted to. Or they're certainly not on the test. I've never asked these. And question 4, I should probably improve upon the beginning table. So each of these problems, if you're watching the video, give me some x values. They want me to find y values by plugging the numbers in for x. And then after I get the y values, I'm going to plot points, because when you have an x followed by a y, that's a point, and then sketch a graph. So the first thing I'm supposed to do for problem 2 is change the x to -2. So I'd go g of -2 equals to -2 squared Negative 2 squared I can do on my calculator, but I don't need my calculator for it. That's negative 2 times negative 2, which is positive 4. That's a point, because g of x, function names and y's can be changed, interchanged. So the first thing I've done is I found a point on a graph, and very specifically, that's the point negative 2 comma 4. So I'll plot it. The next thing I'll do is change the x's to negative 1, so I'll go g of negative 1 equals negative 1 squared, which is negative 1 times negative 1, which is positive 1. That also represents a point on the graph. It's the point x equal negative 1, y equal to 1. The third value of x in the table, when I do it, I get g of 0 is 0 squared. 0 squared is 0. That's going to give me the origin, or the point 0, 0. The fourth is going to give me g of 1, which is 1 squared. 1 squared is 1 times 1, which is 1. That's going to give me the point 1, 1. And the last one I'll do is g of 2, which is 2 squared, which is 4. That'll give me the point 2, 4. And then I pick the points values for x in such a way that if you get the correct y's, you can just connect the points to get a picture. The shape that this graph is going to give me is a U, and specifically it's called a parabola. And if I just connect the points the best I can, this would be a completely adequate graph. It turns out that just like most graphs, they don't end. This graph is going to go up and to the left forever and up and to the right forever. And the points are kind of connected more with curves rather than perfectly straight lines. If I drew a perfectly straight line, it actually wouldn't go through the points. The points aren't, they don't lie in a straight line. For problem 4, it has a shape that's, I don't know if you want to call it an S. I guess we could call it that. I probably should have extended this table to have 2 more x values, because it's hard to see well how this graph looks by just plotting in integers. And when I do my graph, which I'll sneak on some graph paper, I'm going to plot 6 points, and I'm going to get all the y's on my calculator. Not that I really need to, but so for each of these, the first one I'm going to go k of negative 2 equals negative 2 cubed, just because of the fraction I pulled my calculator out. So here's negative 2 cubed, and that gives me negative 8, because that's negative 2 times negative 2 times negative 2. Eventually I'm going to plot the point negative 2, negative 8, but I'll hold off because I have my graph covered. Next thing I'm going to do is plug in negative 1. I'll get negative 1 cubed, and negative 1 cubed is negative 1. So I'm going to plot the point negative 1, negative 1. And then I'll do 0 cubed. That's almost insulting to do on my calculator, but I'll do it on my calculator anyways. 0 cubed is 0. So the third point I'm going to plot is the point 0, 0. Then I do k of 1 equals to 1 cubed. And that gives me 1. In order to graph a polynomial, this is a polynomial, has a domain of all real numbers, if you pick a good collection of x's, you'll get an accurate graph. There's a big, that's a skill that takes a while to learn, to know which points, what x values to plug in so that my graph looks like it should look. And in this class, in a bit, in chapter 5, we're going to do lots of graphing parabolas, U's, and I'll get real specific about what table, what values of x's would be good to plot in, so that when you plot your points, you can see a good representation of the graph. But we're not going to graph many cubic functions, which has an x cubed in it, ever. So the point that I extended is 1/2 cubed. Thank gosh I have this calculator, because this calculator makes fractions kind of a non-issue. So I typed 1/2. Now I'm going to hit the x with the exponent button, and then I'll do my cube. And 1/2 cubed is 1/2 times 1/2 times 1/2, which is 1/8. So one of the points is going to be kind of tricky to plot, but I'll plot it anyways. And then the last point I'm going to wind up plotting, I'm going to find the y value when I plug negative 1/2 in. So I'll go negative fraction 1/2, close my parentheses, exponent key cubed, and I get negative 1/8. So I'm going to plot these 6 points, 7 points, and connect the points, with a, not a line, but with a curve. And the extra points we're going to get, it's going to just make my graph more accurate. So the first point I'm plotting is the point -2, -8. Since I have graph paper right next to me, I pulled it out. Then I'm going to plot the point -1, -1. And then the point 0, 0. And then the point, can't see it, 1, 1. And then the point 2, 8. And then my bonus points. The point 1/2, 1/8. I'm going to go half the way between 0 and 1, and up 1/8 of the way between 0 and 1. So this point's going to be really close to the x-axis, but just hovering right above the x-axis. I've tried to emphasize this region right here is supposed to, between 0 and 1 is supposed to kind of have that bend. It's not a straight line. Between 0 and 1, the graph isn't a straight line. Similarly, if I plot the point, I didn't even write it down, -1/2, -1/8, that point, I go left 1/2, down 1/8, and it's going to be kind of here, and this region's going to kind of have, between 0 and -1 is going to have that sort of bend, and then I'm going to connect through the points. And this is a really nice graph. In brief calculus or regular calculus, you'll learn that this is called, these bends in the graph, it's called concavity, and you'll learn how to use calculus to get those bends. And never in this class, probably for the rest of the semester, will I graph something that has an x cubed. So it's not a deal breaker, and it's not even something you do frequently in Math 151. You don't really focus on graphing x cubed equations, or x cubed and then some more, until if you take Math 212 or 220. So this is not that big of a deal. It's not going to be on the test, but if you get a good collection of points, even if you don't know what a graph looks like, you can kind of guess what it looks like without having a graphing calculator. And that's what 1 through 4 we're just supposed to show you. Absolutely not on the test, though. What is going to be on the test is 5 through 16, and they're super easy problems because I already know how to find x and y intercepts, so I'm just going to do the same thing. I found x and y intercepts earlier in the chapter by changing x's to 0 and y's to 0. I don't have a y, but I can make a y. So for the first step in problem 6, I'm going to change the function symbol to the letter y, because it just makes it easier for me to do the algebra, or at least this algebra. And it's never illegal to do that. Sometimes the function symbol makes your algebra easier and makes your answers more clear, but for this problem it's not. So for each of the problems between 5 and 16, I'm going to find x and y intercepts. I'm not sketching a graph, but I'm going to plug in zeros. So this looks just like a problem we would have done earlier in the semester, or earlier in the chapter even. To find an x-intercept when I have an equation with both an x and a y, I plug 0 in for y. So the x-intercept for this problem, I need to solve 3x minus 12 equals to 0. And this is as easy as it gets in that there's no exponent, so I don't have to worry about factoring. I just need to get the number on one side and then I'll divide. So in my answer to this problem, I was asked to find an x-intercept, and for my answer I can say the x-intercept is the point 4, 0, because when I plugged in 0 for y, I got 4 for x, and points you write x's then y's. And the second part of what I'm asked to do here is to find the y-intercept, and when you have an equation with both an x and a y, you let x equal 0 to find the y-intercept. Y-intercepts for functions are always easy to find. The x-intercepts might require some factoring. So the algebra here on the right side, I don't really need my calculator, but I could if I had to. The 3 times 0 is 0, 0 minus 12 is 0. So I'm going to finish up my answer by saying what the y-intercept is. It's a point. The x value is 0. The y value is negative 12. So I'm writing it as a point. It's got to get harder after this in terms of the algebra for the x-intercept. Might push you a little bit, but the steps are going to be the same for each of the problems up to 16. 8 is one of these problems that's so easy it's hard. So first, I'm going to change the function symbol to y. You don't have to do it, it just for me makes it easier. And then I do usually do x's first and y's second, but it doesn't matter again. Whatever you do, you can do the y-intercept before the x-intercept. So to find an x-intercept when you have an equation with an x and a y, you just put 0 in for the y and solve for x. There's no exponent, so I'm not worried about factoring. Just dividing both sides by 2 to get the x by itself. If you don't remember, any fraction with 0 in the numerator is equal to 0. Could pull out your calculator if this was, if you weren't sure. But it doesn't give me that error message. If it gave me an error message, it's undefined. But when I do 0 over 2, it gives me 0. So this equals to 0. The right side is x. And in for my answer for the x-intercept, it's x equal to 0, y equal to 0, the point 0, 0. Anytime you get 0, 0 for an intercept, an x-intercept, that will also be a y-intercept. For the y-intercept, I let x equal to 0. So I'm going to go y equals 2 times 0. Again, I don't need my calculator for that. 2 times 0 is just 0. So for the y-intercept, I'm going to write it as a point. The x value is 0, the y value is 0. So I go x first, y second, and I get the point 0, 0. 10 is where you might start to break down. Because your algebra skills are, maybe are a little bit weak, and we haven't done anything like this. If you watched my videos from chapter 1, this is section 1.5 where I solve problems like this. Change b of x to y, should I say. And you most definitely solved problems like this if you took Math 092 on campus, and you should have in your last high school class if you didn't have Math 092 on our campus. And if this is your first math class in a long time and you haven't watched the section 1.5 videos, then you might get stuck here and do something that's wrong. So to find an x-intercept, when I have an equation with an x and a y, I let the y equal to 0. And this might stump you, but it hopefully doesn't. This is supposed to be a friendly problem. If you have an equation that's set equal to 0 and the opposite side from the 0 is factored, then you can get the answers to that equation by setting the factors equal to 0. So because this is set up where 0 is on one side, the other side is completely factored, I get the x-intercepts by setting the factors equal to 0. Each of the factors I'm going to solve by getting the numbers on one side and dividing. The 2x minus 5 factor, I'm going to add 5 to both sides and get 2x equals to 5. The 3x minus 12 factor, I'm going to add 12 to both sides and get 3x equals to 12. And then in each of these I'm going to divide. I'm going to have a fraction answer. So I'm going to get two x-intercepts because there are two factors. One of the x-intercepts is going to have an x value of 5 halves, a y value of 0. The other x-intercept is going to have an x value of 4 and a y value of 0. So when I go to write the answer to this problem, I'm going to get two x-intercepts. One is going to be the point x equals 5 halves. I plug 0 in for y, so I'll put 0 in the y part of the point. And then the second one, x equals 4, y equals 0. The y-intercepts aren't ever going to require factoring. They're always going to be reasonably straightforward. To do the y-intercept, I'm going to let x equal to 0. I'm going to go y equals 2 times 0 minus 5, and then 3 times 0 minus 12. I'd do that without a calculator, but this calculator is so easy to use. If you used your calculator, it's not going to let you down. So 2 times 0 minus 5 times 3 times 0 minus 12, just tossing everything in the parentheses like they need to be. And when I hit enter, my calculator tells me the y-intercept should be 60. So I should get y equal to 60. This is because the first parenthesis simplifies to 0 minus 5, which is negative 5. The second parenthesis simplifies to negative 12 because it's 0 minus 12. And then negative 5 times negative 12 is positive 60. And in my answer for the y-intercept, I'm going to say it's x equal to 0 because I plugged 0 in for x, y equal to 60. 12 is the first problem that requires factoring for the x-intercept. So again, I'm going to change the function symbol to y. You don't have to do that, but it's just a little bit awkward if you don't. So I'm going to go y equals x squared plus 4x plus 3. For the x-intercept, I'm going to change the y to 0 and solve for x. So I'm going to go 0 equals x squared plus 4x plus 3. And then now is the first time I'm going to have to factor because I have a problem that's equal to 0 and there's an exponent. That pushes factoring on me, but it's easy factoring. I'm going to make two parentheses. I don't need bottoms up because there's not a number in front of the x squared. My first are going to be a couple of x's. There aren't any minus signs, so my signs are just a couple of pluses. And my last have to multiply to 3 and add to 4, and I think 1 and 3 will do that perfectly. Once you have a problem that's both factored and set equal to 0, then you take the insides of each of the parentheses and set each one of those equal to 0. The x plus 1 factor, I minus 1 from both sides to get x equal to negative 1 for the x part of one of the x-intercepts. The x plus 3 factor, you minus 3 from both sides. So in this problem, I also have two x-intercepts. One is going to be x equal negative 1, y equal to 0, and the other is going to be x equal negative 3, y equal to 0. Now I'll do the y-intercept by changing x to 0. I'll go right to here, and I'll go y equals 0 squared plus 4 times 0 plus 3. Don't really need my calculator, but I have it, so I'll do it. So 0 squared plus 4 times 0 plus 3. And when I do that, I get 3 because this is y equal to 0 plus 0 plus 3, which is 3. So when I go to write my y-intercept down as an answer, it's going to be x equal to 0, y equal to 3. not asked to do any graphing, so I don't have to graph. I just stop once I get the intercept, and that's the answer. 14. If in 16, if they made it onto a test, which sometimes they do, this would be the kind of problem that if you didn't wind up getting 100 and you consistently get A's on my test, this might be where you miss your points. So it's an important problem to be aware of. So just like I did for every problem in this section, I get rid of the function notation and change it to a y. And then for the x-intercept, I'm going to let y be 0. So when I go to write my answer, in each x-intercept, however many there are, there's going to be a 0 in my y-coordinates. So when I let the y be 0 here, this is supposed to be a friendly problem. It's friendly like 2 problems ago because it's factored. And if something is factored and set equal to 0, you get answers, the answers for x, by taking each factor and set them equal to 0. So I'm going to go x equal to 0, x plus 1 equal to 0, x minus 2 equal to 0. This actually gives a solution without extra algebra. So one of my x-intercepts is going to be the point 0, 0, because that's a solution when you take one of the factors and set it equal to 0. My second x-intercept, I'm going to take the middle factor, subtract 1 from both sides, and get x equal to -1. Because the y is 0, I'm writing x equal to -1, y is 0. And for the x minus 2 factor, I'll add 2 to both sides and get x equal to 2. So there's 3 x-intercepts because there's 3 x's in some sense. There's 3 factors. The y-intercept part of this, because it's a function, there's only ever one y-intercept. To do the y-intercept, I'm going to let x equal to 0. I'm going to go y equals to 0 times 0 plus 1 times 0 minus 2. This I would do on my calculator because so many students, when I sneak something like this on a test, don't get the right y. So if you try to do this in your head and you got -2, you fell into a trap. So I'll do this on my calculator. I'm going to go 0 times 0 plus 1 times 0 minus 2. My calculator is not going to be fooled by this. So there's the problem on my calculator. When I hit enter, I get 0. Because this is, by hand, 0 times 1 times -2. And if 0 is in any multiplication string, the whole result is going to be 0. It would be it's super common for students to forget about the 0 and just multiply the non-zero numbers and write what they multiply out to, and -2 would be very wrong, and you lose a point for your y-intercept. So the y-intercept, the x value is 0 and the y value is 0. And if you wrote 0, if you wrote -2 anywhere, it's wrong. 16 is the last one in this grouping, but the end problems really aren't any different if I want to do them with algebra. So in 16, I'm going to change the g of x to y. I'm going to go y equals x cubed minus 3x squared plus 2x. And then I'm going to attack the x-intercept first because it's usually the harder of the pair. For the x-intercept, I let y be 0, so I'm going to go 0 equals x cubed minus 3x squared plus 2x. Because there's an exponent, I know I need to solve by factoring. Because there's a common factor of x, if I don't factor it out first, I'm going to mess up. So I'm going to pull out a common factor of an x. There were 3 x's first. I took one away, I'm left with 2 x's. In the middle, I had 2 x's. I took one away. I'm left with 1x. After the plus sign, I had 1x. I took it away. So I just have a 2 and no x's. That's the first step in factoring. This is a 2-step factoring problem. After I pull out the common factor, I have to factor what's in the parentheses. I don't need any bottoms up because there's not a number in front of the x squared. But my lasts, the signs have to be minus and minus. So my only choice are -1 and -2. And that's good because the lasts have to multiply to 2 and add to -3. -1 times -2 multiplies to 2. -1 plus -2 is -3. So when I finish up the factoring, I don't have my x-intercepts yet, but I have it factored and set equal to 0 so I can get my x-intercepts in one quick step. To get the x-intercepts, I take the contents of each of the parentheses and set them equal to 0. And they each are going to give me an x-intercept. So the first x-intercept that I'm going to write will have y is 0 and x 0, and that's the point 0, 0. The middle x-intercept, or the second x-intercept I'm going to write, I add 1 to that x minus 1 factor, and I get x equal to 1 when y equal to 0. And the third and last x-intercept, I'm going to solve the x minus 2 by adding 2 to both sides, and I get x equal to 2, y equal to 0. The only other thing I need to do is find the y-intercept. For the y-intercept, I'm going to let x be 0. I'm going to go here, y equals to 0 cubed minus 3 times 0 squared plus 2 times 0. For me, I can tell each one of those pieces is 0, and my answer is going to be 0. But if you can't tell, you can just do this. You can go parentheses 0 cubed minus 3 times 0 squared plus 2 times 0. And it's going to equal 0. Because this is 0 minus 3 times 0, which is 0, plus 0. So you get 0 for the y value, and the y-intercept is 0, 0. The last few problems, you can do them exactly like this middle group of problems between 5 and 16, but I don't have to. I could do them with algebra, or I could do them without algebra. If I'm clever, I won't do algebra, but I won't be clever to start. And then we'll talk about being clever. So problem 18 gives me an equation, and it wants me to find the x and y intercepts. I could do this problem just like any problem that I've done so far. To find an x and a y intercept, if I have a function equation, I change the f of x to a y. So I'd go y equals x plus 3. And then to find the x-intercept, I'd let y be 0. I'd go 0 equals x plus 3. No square, so I don't need to factor. Minus 3 from both sides. You get minus 3 equals to x. So in this problem, I don't have a lot of room, I'll squeeze it up here. The x-intercept is the point x equal negative 3, y equal to 0. To do the y-intercept, I let x be 0 into that equation. I'll go y equals 0 plus 3. I get y equal to 3. So the y-intercept is x equal to 0, y equal to 3. This is the correct answer. I didn't intend myself to do algebra for this problem, because although algebra will take you to the x and the y intercepts by plugging in 0 for x and plugging in 0 for y, if you have a graph of a function and you understand how to get x and y intercepts from a graph, then you can bypass the algebra and still get the same answers. Real specifically, this point right here on this graph is the x-intercept, and you can't really read that, but that is the point negative 3, 0. So I could have, without any algebra, got the x-intercept. Similarly, if I knew this point right here, because it's on the y-axis, is the y-intercept of the graph, I could find the y-intercept if I just know how to name that point. It's on 3 on the y-axis, so that's the point 0, 3. And so my intention for problems 17, 18, and 19 is for you not to do algebra and to just look at the graph and pick off the intercepts. And the higher you get in math, that sometimes happens, that there's a real easy way to solve a problem and a hard way, and it's, you know, a gift to be able to know multiple solution methods and to be able to pick out the easiest method. Both methods, the algebra and just looking at the graph, will produce the same answer. So I thought I decided I was going to do number 19, but I didn't, and I don't have it with me. So I only did one problem from this grouping between 17 and 19. I don't have any more problems sticking in front of me. So if you can't figure out 17 and 19, then come visit me or send me an email, and I'll try to do a better job explaining how to do those problems. But they're not hard, because they're going to have a graph. If you look at the x-axis, any point on the x-axis is an x-intercept, any point on the y-axis is a y-intercept. They might have more than one x-intercept because the graph might cross the x-axis more than once. And that is definitely all I have for you. Yep. Alright, so that was a short section. The next section, section 3.5, is going to also be a short section. It is a word problem section, but as word problems go, it's just not the worst word problem section in the world. So there's no reason to be intimidated by it. If you mastered the word problems on the last test, these are actually a notch easier, so they shouldn't be horrible for you. Okay, I'm going to stop it now.